So we're going to be looking at what virtual memory is, how it works, and how it links together with paging. We're also going to be looking at some of the performance issues related to virtual memory, specifically looking at a problem known as thrashing. So although we don't need to know about the page table specifically for this course, I'm going to use the page table to help explain how virtual memory works as a kind of a high-level view. Okay, so if you remember, we have our memory partitioned. Okay, so remember these are pages, so they're fixed size. Okay, so I've got at the moment 3 pages in use, and the page table basically mapping them together. Okay, so each process has its logical view of it, and look at is how that then links into virtual memory. So on the secondary storage devices, we're going to have a special file. Okay, it's known as the page file. Now, secondary storage could be the hard drive, it could be a memory stick or solid state drive. It's going to be some kind of storage device. Okay, it can't be something that you can't write to, obviously. So we're going to use this as a kind of an extension to main memory. So what we have to do is, in order to extend main memory, is to take some of these pages and actually place them into the page file, and that will effectively free up that page in order for another process to use it. So the page file will store pages which have been swapped out. So when we say a page is going from physical memory to the page file to virtual memory, we say we're swapping it out. Now we could swap single pages out, or we could actually swap the entirety of a process. Okay, the operating system can control exactly what goes in and out. In order to do this, the page table will keep track of which pages are in virtual memory and which ones are not. So in this scenario, what I've done is I've taken one page here and I've placed it into virtual memory here. Okay, so now the page table is recording that these 2 pages, so process page 0 is there, page 1 is there, but page 2 is actually on virtual memory. So we can keep track of where things are, and the page table will be responsible for that, and the memory manager will maintain that. So let's consider this situation. We've got 3 processes, A, B, and C, and at the moment process A and B are loaded. Process A already has 1 page in virtual memory, but process C requires 3 pages. So at the moment I've only got 2 pages free, and I need a 3rd one. So another page needs to be swapped out of main memory into the virtual memory. So here I've now done a swap. So process page 0 is located in virtual memory. Okay, so right there. Page 1 is located in RAM, and page 2 is located there in virtual memory. So because pages are fixed size, swapping them in and out of virtual memory is quite easy because they're all the same size. So I can swap one page out and put another page exactly in its place without having to mess around and move any other. So you can see here, process B hasn't been touched at all. Okay, this saves the amount of time we require to move things around in memory, which is an expensive operation. Also reduce the amount of time we need to copy things in and out of virtual memory. So paging is really important when it comes to management. So to summarize, virtual memory is stored on secondary storage devices. Be sure you don't just always say hard drive, because some operating systems may use a different secondary storage device. It's going to store pages only, and we would normally call it the page file. It's a way of extended RAM if that resource is running low. So if I'm running low on main RAM, then I can use virtual memory to extend it. The memory manager would decide on which pages should be swapped out and then copy them into the page file. So it's not the process that has that decision, it is the memory manager, the operating system. And this frees up space in RAM for other pages to be stored. Okay. Just another little point to add to that is this idea that pages are the best way to do it because they're fixed size. I mean, if I swap one out, I can put one immediately back in its place. So what's there not to like? We can have extra memory. That sounds like a great idea. I can have loads of extra memory. The hard drive is massive, you know. Some computers have 1 terabyte hard drive, so imagine using that for RAM. That's amazing. But are there any issues? Can you think of any problems with using virtual memory? Well, as it turns out, there's a really big problem, and it's something we've already come across, the von Neumann bottleneck. There's a speed mismatch between our devices, and if you remember, secondary storage devices are much slower than RAM, which is much slower than the CPU. So if I'm using secondary storage devices to store stuff I would normally store in RAM, well, there's an additional delay if I'm trying to fetch any data from it. So the more we use virtual memory, the more we're trying to access that hard drive or secondary storage device, the slower the system's going to run as a result. So actually, although virtual memory is useful, we want to limit how much we use as much as we can do, because the more we use it, the slower the system's going to get. And here's the problem. If I want to use a page from virtual memory, let's say process A needs to be run. I will need to run it, get it back into RAM. I can't run it straight from the hard drive because every time I try and access the secondary storage device, it's going to be slow. So it needs to go back into main RAM. But the problem here, as you can see, RAM's still full. So if I'm going to use process A again, I need to take a process out and place it into the page file, into virtual memory. And herein lies the problem. We've got a double access now. We've got one where we're trying to copy something into main RAM from the secondary storage device, and one where we're actually trying to save to it. So I've got 2 accesses. I've got 2 pages which need to be swapped around. So consider process A needs to be run, requires all its pages back in RAM. So imagine we need both those pages in order to run this program. We need to make room for it. So we need to identify a process to swap out. So again, let's say we're swapping C. So we swap C out and A go back in. So now can run A. So we've had that big delay. Okay, so it takes a little while to copy onto the hard drive. I'm sure you've already seen if you press save on your computer, it's not immediate. The hard drive light flashes on and off. It takes a noticeable amount of time. But what happens once we swapped process A in? I need to run process C again. We need to swap it around again. So process A comes out, process C goes back in. But what happens if both A and C have been used by the user? So you can imagine you're kind of flipping between 2 windows, you've got 2 processes running for whatever reason. That is quite a common situation to be using more than one program at once. So both of them are needed. Swap A in again. We need C, so we swap C in. A, so we swap A in. And we get into a loop. We get in and out, in and out. We call this problem thrashing. And thrashing is where I'm continuously swapping pages in and out of virtual memory. It's normally caused when I'm in a situation like this where main RAM is pretty much full. So I've got a large amount of RAM being used. The more I rely on virtual memory, the slower the system's going to become because of that speed mismatch between the secondary storage devices and RAM. Okay? It is a massive noticeable slowdown. You'll really notice if you've got a small amount of RAM in your computer at home. You probably will notice this if you've got too much stuff open. You'll start to see the computer getting really sluggish. This also happens if you leave it on for too long, especially with Windows, because a lot of processes have been put into virtual memory to kind of free up RAM as kind of a default. So It's important to get this now into your notes. Now, before I talk about this, I want to just say one last thing. Just a little example. I'll show you what I mean about this notable slowdown. I'm sure you've done this before, where you've got something open, you've minimized it, and then maybe you've not used it for a while. Maybe you've got Word minimize or Internet Explorer minimize or whatever, and then you go off for half an hour now or do something, and then you come back and you try and open up that program again. You maximize it, and there's a delay. It doesn't maximize immediately. It waits for a couple of seconds, and all of a sudden then it appears. Okay, you notice the delay. You notice that it took a while. What's happened is that because the operating system realised you're not using it, it's thought, well, you're not using that, I'm going to put it in virtual memory because that frees up RAM for you. And then you try and use it again, and because it's in in virtual memory, it needs to copy back into RAM before you can use it, and there's the delay. So you can actually see the problem with virtual memory just in your day-to-day computing. So, notes task. Explain the purpose and need for virtual memory. Explain how pages are swapped in and out of memory, and explain why paging aids in this process. Now, this point here is really important. So it's a point that sometimes people forget to talk about. And then describe that problem with virtual memory. So virtual memory, although it's useful, it's not a perfect solution. There is massive problems with using it, and make sure you specifically talk about thrashing. Now, to finish off for subject clarification, so remember this is the second part of the Memory Manager unit, so I've underlined the bits which are related to it. So how this aids the transfer of memory, for example, virtual memory, so how fixed size pages relate to virtual memory. And also, candidates need to understand what's meant by virtual memory, why is it needed in a computer system, so this idea of it's extending RAM if we start to run low on that resource. Candidates need to understand how paging is used in virtual memory and the benefits and drawbacks of having it and using virtual memory in a computer system. So benefits is this idea of extending RAM, drawbacks is a speed mismatch between secondary storage and RAM.